Okay guys, 2004 4B, a smooth wedge of mass 4 kilograms of slope 45, rests on a smooth horizontal surface. Straight away I'm eliminating out any friction that I need to worry about. It's just not going to happen. Particle mass 3 kilograms is placed on a smooth inclined face of the wedge. The system is released from rest. Shown in separate diagrams, the forces act on the wedge and on the particle. Okay. I'll start with the easy one, the particle. So gonna have here is the particle here. It's 3G is going where, guys? 3G is going directly down. Its reaction force, we can call it N, we can call it R, doesn't really matter. I'll call it R, R1. Goes straight up, okay? And sorry, yeah, that's meant to be exactly perpendicular to the plane. Okay, that's R1. 3G down. That's all you really need to write for the forces there. Now, I will specify its acceleration. I gave it acceleration A. So, if you were to imagine this is a wedge, not a plane. See the way it says wedge? What's the difference between a wedge and a plane? Wedges move, planes don't. Okay, so this acceleration A is the acceleration relative to the wedge. It's if the wedge wasn't moving whatsoever. Everybody got that? So if that was going down as an example at 5 meters per second and the wedge was moving 3 meters per second, we're just saying that relative to the wedge, if this wasn't moving at all, it's still going 5. But overall, it's actually not going 5 diagonally left down because it's getting affected by the tree moving right, because the object it's on is actually also moving. Okay, but you don't have to get that technical. I'm just specifying that the language is that it's relative to the wedge. Okay, now we're going to try and find exactly what equation we're looking for, just dissecting the language of the question. Okay, so showing separate diagrams, the forces acting on the wedge. I'll finish out the second one in a second. Find the acceleration of the particle relative to the wedge. Okay, and finally find how far the wedge has travelled when the particle moved a distance 1 meter down the inclined plane. I need to know how far the wedge is going, and then so I'm going to need both accelerations as it turns out, just for this specific question. Okay, so let's continue on with my wedge then. I'm going to draw the wedge next. Forces acting on the wedge. Okay, can anybody tell me what force is acting on the wedge? See this R1 that was acting diagonally left up? That is going to also act diagonally right down on the wedge. When you pick up something, they experience a force up, but in turn you experience a force down. Okay, you're not supporting the particle's full weight because the particle is sliding down the face of the plane. That's why we only absorb a certain component of the weight. Okay, we have 4G acting directly down. Can anybody tell me what might act directly up? Anybody? R2. R2 is acting directly up. Okay, and then finally we need a new acceleration. I'm going to call it acceleration F. Okay, and the next thing I would like to do is I want to break up this. See this 3G triangle here? I'd like to break that up a little bit. So any idea what I could do here? What angle is this in here? If that was a 30, that would also be a 30. So it's 45. So it's 3G over root 2 because it's 3G cos 45. And 3G over root 2 because that's 3G sine 45. Okay? So the next thing I gotta do, does he use F or P for that one? I'll go figure. I actually changed to P. Yeah. I'm going to change that to P. Acceleration P as opposed to acceleration F. Okay, now, do you see the way I'm going to talk about the wedge? And when I'm going to talk about the wedges, I'm going to talk about the wedge in two different directions. I'm going to talk about it parallel and perpendicular. Okay, one of them I'll need, one of them I probably won't need. Okay, so for the time being, I'll show you both, and then we can decide on the decision we should have made going backwards. Alright, so what I do is I write 3G parallel to plane. Now there's one problem with doing parallel and perpendicular to the actual plane itself. It's that this acceleration here hasn't been broken up parallel and perpendicular to the plane. So to do that, what you're going to do is you draw an extension line across. So you go in the direction of P. Everybody agrees that that is acceleration P. I then draw the same plane here. So I draw 45 degrees upwards. If that was a 30, I draw 30 upwards, okay? So I'm going to draw 45 upwards. And then I stop, and then I do parallel and perpendicular to this 45 degrees. What this will do is it will break up the wedge's acceleration into components parallel and perpendicular, which are compatible with the direction of the particle's acceleration. That makes sense? Hope so. Now, you're going to get here is that's going to be P cos 45, P sine 45, which in turn is P over root 2 and P over root 2. Okay, please remember direction, that's going up and that's going diagonally down onto the wedge, okay? So, when we're talking about the 3 kilogram particle down the wedge, okay, we'll start off with force going diagonally left down. What else goes diagonally left down? Anything else? What force? 3g over root 2. The weight going downward is 3g over root 2. Force equals ma. In this case it's 3a. But what's actually the acceleration? What is the acceleration? Most people just inclined to say a, wouldn't you? Yeah. Now, because this is going diagonally left down, I have to lead with the acceleration that's also going diagonally left down. Okay? Is there any acceleration going diagonally right up? In the opposite direction? P over root 2. Because it's not going diagonally left down, it's going diagonally right up. It acts in the opposite direction to A, therefore reduces the effect of A. So that's your first equation. So it's going to be 3a minus 3p over root 2 equals 3g over root 2. Okay, that'd be our first equation. I might be inclined to multiply both sides by root 2, and that will help me get rid of any fractions, especially surd fractions. Won't be too fond of them. Okay, that's done. What we're going to do next is we're going to do the wedge, perpendicular to plane. Okay, 3 kilograms perpendicular to plane. What do you think this time, guys? Is there any force going into the plane, into the wedge? Yeah, this part here, right? So what we're going to say is force going this way is equal to 3g over root 2. Anything else we can get from that then? Minus R1, isn't it? Because the R1 is a force that's supporting it in the opposite direction, so it's going to be minus R1. Okay, force equals ma. What is actually its acceleration going in that direction? Anybody? Sorry? Nope. P over root 2. Remember, because the particle sits on the wedge's acceleration basically acts as its own. So you have to add it to its own one, okay? And then that equals 3g over root 2 minus R1. Then I'm going to multiply both sides by root 2. Everybody alright with that? Okay, so that's the second one. That's 3 kilograms perpendicular. For any particle, you'll only ever have two equations to use. Do wedge what goes up equals what goes down, otherwise known as statics. Because the wedge is moving directly to the right, so obeys force equals ma. Now, is there any part of the wedge that's components don't line up left and right? Any force on the wedge that its components don't line up left and right? R1. R1 needs our immediate attention, okay? So if we were to draw this line down here, that'd make that one 45, exactly the same angle as this one here. Oh, sorry. What it would do, technically speaking, this angle here, although it is 45, that would be the same angle in here, no matter what that angle is, once it's acute. Okay, so what we're saying, when we look in at R1, we're basically saying that if R1 goes this way, which it does, we're saying that that is the same angle as the wedge. And in this particular case, it's 45 degrees. That makes that R1 over root 2. And it makes this one R1 over root 2. Everybody happy with that? Alright, so here's what we need to do next, okay? So the wedge is force equals MA. It's going directly to the right. What weight is the wedge? 4. Now, here's a question for you. Is the wedge influenced by the particle's acceleration? Should there be any A component in here? The answer is no. The particle sits on the wedge. The wedge doesn't sit on the particle. The particle, because it's a passenger on the wedge, is affected by the wedge's acceleration. Okay, because it's actually on the wedge. It's not the other way around. Okay, the particle is affected, the wedge is affected by the particle's presence, and that is taken into account via R1. Alright? So there's nothing else to worry about. So when you're talking about the wedge is always just its own acceleration. It never has like A and P mixed in. So it's going to be 4P. Now what's MA, guys? 4P is the force, yeah. So what forces are acting left and right now? So what force drives the wedge to the right? The only force I see acting even remotely to the right is R1. And we've broken up into its component that's going directly right, which is going to be R1 over root 2. All other forces are going directly up or directly down, and therefore have no influence on left to right. So that's this equation here. Now, if we were to do wedge up and down, what could you tell me would happen here? Otherwise known as statics, okay? So forces up equals forces down. I'd say that R2 would equal what, guys? 4G going down. What else goes down? R1 over root 2. Now, we can see that the last equation has no accelerations in it, does it? So the wedge going up versus the wedge going down has no acceleration. Therefore, we can't use it to find any accelerations for our question. Therefore, 9 times out of 10, it's completely useless to us and wasn't worth even going into. Anybody got 4 equations, okay? And what makes my targeting, what I'm talking about targeting here, I have A here, P here. That's the parallel to a plane equation, isn't it? Would everybody agree with that? Now, this is one of the most important things you're going to hear all year on this, okay? Do you see the perpendicular to the plane? Perpendicular to the plane only ever contains the acceleration of the wedge. Does everybody see that in blue here? If you resolve a perpendicular, all what you're going to get is the acceleration of the wedge, not the acceleration of the particle relative to the wedge. So if your question only asks you for the acceleration of the wedge, getting parallel to the plane is a waste of time. You go for perpendicular to the plane twice, combined with the other equation, which is the wedge going left and right, that also has the acceleration of the wedge. Stop there. So guys, what we can see here is that the wedge's forces up versus forces down actually contains basically no acceleration information, so therefore we can just get rid of it there. We're not going to use it. Okay, now I have all 3 useful equations. Now I have to set up a system to find out what the acceleration of the particle relative to the wedge is. I need to find out what A is. Okay, doesn't matter what order I do it in. So, find out what A is. 3 equations. Let me see. We will go for R1 equals 4 root 2p. I might substitute R1 into this equation here. So I'm going to get a... Actually, I will highlight all three equations before I begin, just so for easy, so I can find them easy. Okay, there we go. Now I'm ready to go. It's a good exam technique as well. Highlight as you go along, so you can for easy access to find where they are. Okay. So I'm going to put this into 3p equals 3g minus root 2 times 4 root 2p. I'm going to get 3p equals 3g. That's going to be minus 8p, isn't it? And long and behold, I found p quite quickly. P equals 3 over 11 g. This means I can also find R1 quite quickly. R1 is 4 root 2 multiplied by 3g over 11. That to me looks like 12 root 2g all over 11. And then finally, trying to find out what a is. 3 root 2a equals 3g plus 3p. Oh wait. And then 3p is 9 over 11g. Are we happy with 9 over 11g? Okay. 9 over 11g for 3 times p, because it's 3 times 3g over 11. Okay. And then once that's dealt with, we're then going to add on 3g. 3g is the same thing as 33 over 11g. And that's over 3 root 2a. We're going to get next then is, what's it going to be? 42g over 11. 3 root 2a. Divided by 3, I'm going to get 14. Bring down the root 2. A equals 14g over 11 root 2. Not the nicest number that's ever existed, but it's the correct number. Okay, there we go. Done. So we've done the two of them. How far the wedge has travelled when the particle has moved the distance 1 meter down the inclined face of a wedge. Everybody write that? Inclined face of the wedge. So we need to do u vast, and when we do u vast, UVAST, that's for the particle. I'm also going to set up a u vast for the wedge. Okay, so the problem with the particle is, do we use the 11 root 2 or yeah. Okay. So, when you're talking about the particle in isolation, the particle relative to the wedge, you're only talking about A only. So, although the P is affecting it, the P affects its overall motion, it's like walking on a train. When you walk through a train, it's the same effect as if the train wasn't moving whatsoever. You can still cover 10 meters along the dart in the same way you would if the train was completely stationary. The train's movement has no effect on how you travel actually on the object itself. In the same way, A is going to be taken alone in isolation here, okay? So the S value, guys, what's the S value? Going to be 1. The A value is this on its own, which is 14g 11 over root 2. Its phi we don't know. We assume it starts from rest, u equals 0. We need to find out what is the time. Okay, so any choices there, guys? S equals ut plus a half at squared. So I'd go after 1 equals a half. What's a half? 14g over 11 root 2. Then times t squared. Then what I'm going to get is 1 equals 7g over 11 root 2 t squared. Bring that underneath. 1 divided by 7g over 11 root 2 equals t squared. Your t value is going to be 0.4762. Just put it all into the calculator, guys. The number 1 divided by that fraction and replace g with 9.8. Okay, so now you have your time. You go to your wedges u vast, wedge equals 0, We don't know. We know the A value is 3g over 11. We don't know S, that's the point of the question. We know that T is 0.4726 or 62. My recommendation is S equal to UT plus a half AT squared. S therefore equals a half 3g over 11 times 0.4762 squared. Put all that into the calculator and you get S equals 0.303 meters or 0.3 meters. Okay.